Welcome to another episode of Series C Growthonomics. We will continue our Mythbuster series, and today we are debunking one of the biggest myths which is trending, called AutoML, no data scientist needed. So just like 4, 5, 6 years ago, AI and ML became big. What's becoming really big in keyword is auto machine learning. And the premise of auto machine learning using some of the libraries called AutoVeca. There's also Auto Scikit-learn. There's also Auto PyTorch, and more. The premise of all of the Auto ML libraries and packages is that all of these steps, data processing, for example, or processing as well as pre-processing. There's a feature, you can call that engineering in this case. I don't know whether, I don't believe that's the level of engineering AutoVeca can do. Is, I wouldn't call it really feature engineering, but like feature engineering, your model selection, and it won't select one, it'll select many out there. Your hyperparameter tuning, there is, like, let's say you're using machine neural networks, your initial what is called initial architecture, right? Like how are you going to set up your neural network? For that it's also auto doable, and so on. The whole model output or results, so analysis of results and a few others, right? So I'm not being comprehensive, but essentially the idea is that your auto ML can sort of automate all of this. So hey, wait a minute, you don't need data scientists. But for all of you who have real business problem and you're thinking about, and you're being lured by this keyword of, hey, don't hire data scientists, buy our tool or whatever have you. It has AutoML already pre-built into it, and you can just build models without actually needing a data scientist. I really want you to think hard, and here's why. So when a business problem comes to the place, and many of you are well familiar with this, and I talk about this and many of this. When a business problem comes to forbearing, so for example, you are a fintech startup. Let's talk about the last few ones that we've been talking about. You are looking to do fraud detection, and you're a fintech, you process lots and lots of billions of transactions, and you're going to use AutoML for fraud detection. So if you think about it, when somebody comes in with a problem set for machine learning or let's say even AutoML, they don't start with data. It's starting with a problem. So as against what can be automated starts from data processing or pre-processing. You in real world will start from, and this is Badir, I've laid out the chevron for Badir, but you start from business question, what kind of fraud we're going to be able to catch, what are the constraints, who are ready to take actions, and so on and so forth. You are actually human persons are sitting around the table, some from fraud, some from product, some actually data scientists, who are having this conversation to frame your business problem. So here, as we just talked about, AutoML is going to fail. It's not going to work because it doesn't start this step. The next step is analysis plan. And in this case of machine learning model, it's a very exhaustive process. You want to think about your analysis goals, very clearly define your objectives. The biggest step that is important here is hypotheses. What do you believe drives fraud? And why hypothesis is important is you don't want to boil the ocean, right? So you don't want to boil the ocean because you only want to, even in this AutoML case, you can actually connect the pipes to your data lake and actually have it get everything in the world. We are theorizing that you really don't want to boil the ocean because not everything has value, and why would you spend your time? So this hypotheses and this business question, all these steps are a way to narrow down your focus. The other thing a hypothesis does is rich feature engineering. Your very complex, and often this is the highest value features. If you really ask me, the highest value features are those which are coming from hypotheses. Like, if the IP is such, and the sender address and receiver address is such, and blah and blah and blah, then possible fraud. That kind of logic cannot be arrived by AutoML, and those tend to be the richest features. Can you build 150 models in your machine learning model and get to some semblance of that? Possibly, but this single feature is going to outweigh many others. This might be equal to 100 models you build, because this captures that dynamic. So and many other steps that happens, and there again, analysis plan, actually humans are talking to other humans, time constraint, project plan, backup plans, all of that, your AutoML won't work. So again, here analysis plan won't work. And then collecting of only relevant data, validation, some of that again can be done using can use some automation, but really AutoML will start from the data. So this step also AutoML cannot do. Now this is all the steps when we just talked about data in insights. When we start talking about data pre-processing, feature engineering, model selection, there are many other steps in between: outlier treatment, missing treatment, all of that. That's when you can possibly use AutoML. But I will say that given there's a step that we use called base model building. That is a perfect application when you're trying to just build a quick and dirty model for what is the capability, what are we looking at, what is the base model. That would be a great application for like, let's say, AutoVeca. But other than that, when you start getting into really engineering, using stuff, and hyperparameter tuning, there's a lot of intuition. Look, what is the distribution of your variable, how it visually interacts with your dependent variable? All of that is going to define the model you'll choose, the kind of, let's say, distance you're using. Why are you using a Jacquard versus another distance? So all of those are I would say, while you can have some applications, I would say some application here for AutoML, most of it will not be very feasible, or you're not going to get very good results using just AutoML. And then the recommendation step is all people. You having conversations with people saying, this is what we have found. Often machine learning is black box. You may not know, the parameters of you don't know the weights of different variables, and that's fine. But you still are having some conversation about, this may be driving your results up. This may be biggest fraud alerter. This particular, the address of the IP address is one of the biggest in our fraud detection, so on and so forth. Those are good insights. And then deployment again cannot be AutoML. So basically, there is a very limited application for building potentially base model using AutoML, but rest of these rich steps that you're going to need to do, connecting the business question back to recommendation and actually model deployment, cannot be and should not be done, especially if you have a lot riding on this. And if you don't have a lot riding on this, don't do this model, don't build the model. But if you have a lot riding on this, AutoML is not going to be your solution. And so don't be lured by it. You absolutely need a data scientist and a good one to handle that. Hope that was useful. See you next time.